Our next presentation is a business technical duo, and during which we should find out how this company is able to give business insights and set their data free by adopting the big data technologies. So join me in welcoming Laurentiu and Alex from eMAG. Laurentiu, Alex?
Thank you very much. Hi. Should we have a countdown here? Thank you all for coming. Um, we'll be discussing today transforming data at a scale with the eMAG data platform. And we'll be discussing transforming data at scale in two ways. The first way is the sheer size of the data, things that you would expect. Speaking of terabytes and petabytes of data, but also scaling the people that are transforming the data. And this is where things get even more complicated. I'm a tech guy, but working with people is always more complicated than working with computers. So what we'll be discussing today, we'll present ourselves. We'll discuss a bit about our data journey in eMAG. We'll discuss about our platform, our data platform, the requirements, and a bit about the implementation, the challenges that we're still facing, and a bit about team organization. One thing that I need to emphasize is that what we're presenting here today is work in progress. As I'm saying, this is never done. It's always evolving. We're always doing something new. I give you Alex, our data platform team lead. So Alex, a few things about yourself, please.
Hello, everyone. It's a pleasure being here. A few small words about me. So I'm a computer science undergraduate from the Polytechnics University of Bucharest. I actually started my career as a backend Java engineer and switched to data engineering afterwards. And I can honestly say I'll never switch back. So my journey in eMAG started 4 years ago when I joined the big data team in its early stages. And for the last few months, Laurentiu and the team gave me the opportunity to work on the new shiny data platform for the company.
Cool. Thank you, Alex. About me, I am the BI and ERP director for eMAG since February 2020. I came at the same time with the pandemic. I graduated the same faculty as Alex, but many years before. I graduated Alexandru High School in Alexandria in '98. I always say this, I won't say why, but I also started developing software. I like to joke that I started writing Linux drivers and I ended up doing Excels after 20 years of experience. So I joined the eMAG in 2011 as a software developer. One of my first jobs was to optimize the systems for the first Black Friday, and obviously I wasn't able to optimize them enough. It took a few years. So yeah, and leading people in eMAG since 2013. I've been a team lead and then a team manager in software development up until I switched to the data team. Now, about our data journey in eMAG. We started BI with ClickView, connecting to the 3 applications that we were having at the time. I think when I came in 2011, we were still close to that. The 3 applications were the website, the backend, which was actually being accessed by HTTP server, and the ERP. Now, things evolved from that kind of naturally, and the 3 applications became, I think, 300. Who knows? No one knows anymore. They're microservices, some chunks of monoliths, all kinds of things. And we ended up still with reports connecting to more and more data sets and creating some really big and slow data silos. Because the company grew, our business grew, and this is good, but we had to ingest more and more data and build more and more use cases. So we ended up with these all kinds of slow data silos. They were in ClickView reports, they were in Excel's, hundreds and thousands of Excels. And we had lots of duplicated processing, and we still have it, so let's be clear about this. And what happens is someone takes a report, copy paste, and makes a few changes and publish. We have a new version. Now, we've discussed a lot during these days how the data used to be consumed. People were looking at the dashboard, at the report, and they were exporting to Excel, of course. And that was enough for many years. But then again, some new kinds of users started to show up. We started to have data scientists, then data science teams, then some citizen data scientists, people trying to go into conferences and seeing all kinds of new tools and say, hey, I want to use this, I want to connect to that data from that report and join it with data from that other report, and I want to build something new. And I say, well, it's not that easy, but why is not easy? Because I see the data there. Yes, but the data is there, but you don't have a connector to use it from there. Some other new way is that applications are saying, hey, we can make decisions based on the data that you have computed here. And we can load this data back into our applications. We have the marketplace that wants to show statistics for the marketplace sellers in eMAG. We have marketplace trying to make recommendations for sellers based on the data that we calculate. So we have to route that data back to the application. So we have all that ecosystem with microservices. Then you go to some report in Excel and you have to feed back. So this is something that it's painful, it's prone to error. Now, a few years ago, when did it start, Alex, with the big data team?
I think 4 or 5 years ago, something like that. 5 years.
Something like that.
Probably.
We started looking into big data, and first as a proof of concept, and it worked, and then as offloading use cases that were too big for anything else that was in the ecosystem. And then we started and said, well, everybody's going into that direction. Everybody is using distributed processing, everybody is using real-time use cases, and everybody's using Spark, and everybody's using distributed SQL engines. So the big data ecosystem becomes the data ecosystems, and we said we have to use more of that. But the thing is, there are some technologies in the big data world, and Spark mostly, and ingesting data, and you'll see later, that are scary for many people. So we have all these BI developers, this is how we call them, people that know very well the ClickView script, and they know the data, and they know SQL a lot. They know how to manipulate the data, but not with these tools. And what we're trying to do is somehow make ends meet. Educate these people so that they can use newer technologies, and also try to abstract away unneeded complexities from the technology and bring it closer to the people that know the business and how to manage, how to process the data. So we said we need a platform that would help us bring the technology closer to the people. And we started looking at what they already know, and we said we need to use SQL because everyone knows SQL. And I've seen people asking me many times, do I have to learn Spark now? Do I have to learn Scala? Do I have to learn Python? And I say, okay, it won't hurt. So learn whatever you want, it won't hurt. But we can do lots of things with what you already know. And this is one of our requirements. So in order to scale the number of people that are able to process data. Now, we also wanted to have code versioning. This is the software developer in me speaking. When I first came to the data world, and I've seen no code versioning for report code, I said, well, how is this possible? It is possible, but we want to change that. We want to use distributed processing, and I've seen this problem here a few times about batch processes that take hours, but in the range of tens of hours. And when you have a job that starts after midnight sometime, that processes data for yesterday, and it runs for about 5 hours, and then it crashes for a reason, and then you have to take it back again, well, that's a good recipe for the CEO calling me at 8 a.m. in the morning, I don't have my data for yesterday. So what we're trying is to use the power of distributed processing so that those long batch jobs take not as long anymore. So we said we want to abstract away complexity, and you will see later in the presentation why that's important, because the complexity that we ended up having in our ecosystem in I think we have over 20 years of eMAG now. It's a lot. Now we want to be able to test and document data, and we also want to have lineage. And this is what all these things are required for. We want the people that are working in reporting and in our old data warehouse, we want to be able to use all these new technologies because they are the ones who know the business. And in my experience, it's harder to understand the business flows and the way those are represented in the software systems than to learn some newer technology, especially if that newer technology looks a lot like what you've been using before. Now we have lots of things in our ecosystem, and we couldn't just have a project like 1 month or 2 month or 1 year project and say, hey, we're starting to migrate, and this is how it will look like, and we're starting now, because we have to first decide and test what's best for our use cases. And during our testing process, we realized that not everything works like in the conference presentations. I was joking this morning that we should have some session where we all bring our laptops and show all the mess that we actually have in our production systems, because it's all shiny here in the conference. So what we did, we started to do things that helped us and worked in small steps. So we started, for example, dumping data that was processed in ClickView with ClickScript into the data lake. And in the backend, it's the same old thing, but we have that data available and people can connect to it with data science tool. We can stream it back to applications, and it's still the same mess in the backend, but we are getting the customer off our back. We are giving them a way to access all that data. we triggered the Spark jobs from cron, and this is how the big data team has been working a lot with all kinds of use cases. We've been connecting Dremio. The ones of you who watched us lately, you know, we're using Dremio a lot, and we've been connecting Dremio directly to the staging layer. So we are ingesting data from applications to the data lake as it is, and connecting Dremio to that staging layer so that people can do their own analysis and VDSs, they are called in Dremio, where they can quickly come up with some insights. And we even connected Dremio to the applications databases themselves, and people were able to join right away data with from different sources with minimum involvement from the data team. The next thing, once we had data in the data lake ingested, we triggered Impala queries from ClickView and ClickSense, because this is what we had. As I said, the BI developers didn't have the knowledge to use Airflow or things like that, or Linux for a matter of fact. And what they did know, they were able to run SQL from their environment. And they did just that. And they realized it works much faster. So they didn't have all the benefits of the modern data platforms. They didn't have code versioning, they didn't have modern deployments, but they have the environment, the familiar environment they were working in, and the power of the data lake cluster. Then we started triggering Impala queries from Airflow, and people were still using SQL, and they started to understand what a modern ecosystem looks like. And then we said, okay, we have a data warehouse running on a classic database, and we said, let's try to use dbt, because everybody's using dbt these days, and let's try to use dbt and move those pipelines to the data lake. And we need to still be using SQL, but abstracted away in some form. And we've been using dbt with Impala and dbt with Spark, and we'll tell you how that went. Now, in order to test drive this platform, because in theory, again, everything is easy and shiny, but we took some of the most complex use cases that we had. So we said, well, this platform should be able to handle these 4 use cases. And one is clickstream and traffic, and this one's the biggest. The orders, which is a quite complex one, because it has to deal with lots of particularities of what an order is. You would expect this is simple, but it's not that simple. What a relevant order is, what a test order is, because we're doing lots of tests. We are building a users dataset and an offers dataset. The offers dataset is a good one because people come and ask, Black Friday is coming, and people start asking, well, this is actually not a good price. And then it's hard for us to tell you if it's a good price or not, because we have the people doing the promotions who say, well, this is a good price. But then you have all kinds of things that form the price and the actual offer. So we are working a lot in having a data set that is easy to use and that lets you say, well, this product on this particular day had this price at this hour, and it was sold by these sellers, and this is the seller that actually had the buy button that you could actually use. So yeah, we need to make our data platform able to handle all these use cases some way or another. Now, okay, this is the Pokemon slide. You know that you never know which one are big data technologies and which are Pokemons. And Uh, when you show this to BI developers and experienced developers or data warehouse developers that have been using only ClickView or only MySQL or only Microsoft SQL for, I don't know, 5, 10, 15, 20 years, it starts to look scary. So do I have to learn all this all of a sudden? And uh, this is what we're trying to abstract away. But the question is, why do we have to use all this? So maybe, Alex, this is where you start to help me a bit. So maybe you can take some of these technologies and tell us a bit about them.
Yeah, sure. So you can clearly see here, like we're running a pretty standard Cloudera technology stack with some minor additions like dbt, Dremio, Tableau, and so on. Tools that are actually either brought into the ecosystem to enhance our current capabilities or to replace the Cloudera alternatives that weren't actually matching our requirements. Now, deep diving into the actual tech stack, on the ingestion side, you can see we are accommodating sources such as MySQL, MS SQL, MongoDB, and so on. That list is restrictive, and we're constantly growing it. The actual batch jobs, the actual ingestion pipelines are mostly written in Spark and Scoop for the batch ingestion. And on real time, we rely on Kafka Connect paired with Debezium for change data capture, NiFi for incremental updates, and even Spark Streaming for those sources that have like high throughput and are later used in streaming analytics, with really important streaming analytics. So the use case here would be traffic. On the storage side, we're relying mostly on HDFS for keeping our data. On top of it, we've added Hive in order to add new functionalities to organize and structure our data. On the other side, we have also on HDFS, we have HBase paired with Phoenix. This is for those requirements that like require pretty faster transaction speed. Kudu is our go-to tool for data streaming analytics, and Solar and Kafka are usually ways we expose our data to other applications inside eMAG. For example, Solar here is used in part of the payment process, so it's it has like quite high requirements, quite high speed requirements. Processing, as Laurentiu said, it's mostly done in Spark and Spark Streaming. They usually do the the heavy lifting. Impala we started recently using Impala to offload workloads from ClickView to the data platform. And dbt is the new kid on the block, which Laurentiu will talk more about. Workflow orchestration, Airflow, pretty standard. In data discovery and querying, we also have Cloudera and Dremio that Laurentiu talked earlier. It's a lakehouse platform. We have it synced with multiple data sources in eMAG that don't actually have replication in our data platform, so it makes access to data faster. Data visualization, ClickView and Tableau, and for data governance, we started using Data Hub as an alternative to Atlas. As you can see, there are like a lot of logos on this picture. So our technology stack is quite large. The thing is, we haven't found a silver bullet for all our use cases, mainly due to incompatibilities between different tools. But we're starting to see improvements both from the Cloudera side with recent updates and also third-party vendors that are writing drivers for things like this.
Yeah. I need to say that in this part there are many other tools. So this is what we know that people in our department are using. But once you make the data available with things like Dremio or Impala and have it at least a bit documented in a catalog, you have people connecting to the data with Power BI, with Superset, with Redash. with NIME, with all kinds of, with Excel. So they connect the data directly with Excel, and this is how they want to consume it, so they can do it. And we're trying to concentrate on making the data available here at this layer, available and documented, and people can use it however they see fit. And these are use cases that we keep closer to with machine learning and applications, but they are using the same data. It's not copied all over the place. But this looks spooky, and what we're trying to do with the data platform is make it look more like this. So all those things are still there, but we're trying to show to new people that we're onboarding. We say, well, this is what you'll be working with, and this is at the edge. This is the kind of stuff that you'll be using in your day-to-day work. So I need to say one thing here about ingestion, because it disappeared completely. What we're doing with it, we're using, we're having templates, and people are filling in some forms, and they say, well, I want this data brought to the data lake. And for now, we are just having support tickets created from those forms, and some people are manually creating the pipelines to ingest that data. But we plan to automate this in the future, but still, even so, this thing, which is complicated, it's abstracted away from the users. They don't have to worry about ingesting stuff, which is complex. Yeah, what else do we have, Alex? We have DBT. What we're doing with DBT?
Well, we're creating like an abstractization layer for developers in order to interact with Impala and Spark in a more seamless way and a simpler way. So,
yeah. So basically, what we're doing, we're abstracting away things for two kinds of people. The first kind is developers, and we're abstracting away all that ecosystem, and they only interact with DBT, Airflow, and Git, so that they know when to schedule their jobs. They're writing SQL in DBT, and they're versioning their code with Git. And the second thing, we are abstracting away the discovery and the usage of data with the query engines and the data catalog. One more thing about the data catalog. We just started talking here about data mesh a bit. I've been to Big Data London a month ago, and everybody's talking data mesh. So I'm sure we'll be discussing more and more about this. And we started discussing internally. And the first thing that we realized we need to do, we need to kind of document data where it is. And we need an extensive catalog so that we know where the data is. So we've been looking a lot into trying to bring all the data in the same place. And it seems that this battle cannot be won. So at this point, we want to see where the data is. How does it look like? What's the lineage? How does it go from one system to another? And we decided to use Data Hub for this. So it's the first project, real life project that we're doing towards the data mesh. It's having a comprehensive data catalog that documents data where it is. So yeah, we said DBT is central for all this thing that we're doing, and we've been experimenting with it, and I don't know, we kind of said, well, we don't really need it, but then again, after testing it, we saw that it covers, you know, in blue, all the things that we wanted from our data platform. And it gives us even more. It gives us some project organization, because as I said, those projects with copy, paste, copy, paste, copy, paste, they all look different, and every developer's write whatever they want. It gives you a decent amount of portability. This is something that at some point we expected that you just write some code into DBT and it will compile it to every platform that every target that you're compiling for. It's not right. It's not fully like that. I mean, any particularities that the SQL engine that you're using has will be seen in DBT. And if you're going, for example, from Microsoft SQL or MySQL to Impala, you need to adjust a few things, but it's still a lot less work than rewriting everything. And it also works with cloud data warehouses, and so it gives you a decent amount of portability. It brought us Jinja, which brings some things that are not readily available in SQL, like dictionaries, lists, all kinds of loops and decision logic, macros. It can export lineage and docs to an external catalog, because we're having this issue where all those things in our ecosystem bring lineage, documentation, maybe not all of them, but most. But what happens when you have this system who has its lineage and documentation that exports data to this system? Well, usually that link is not covered. And this is cool about DBT, that it can export this information in a machine readable format, and you can use it and import it in some other tool. And it has a huge community. Everyone is using it. I won't give you the code. So,
okay, I can see the timer is quite low here, so I'm gonna go. I'm gonna do it fast. Okay, so the main idea here is you've seen how our infrastructure looks and where we started from and where we're trying to get to. And doing that with DBT, I'm going to give you a brief overview of how our DBT solution looks. Up until this moment is not complete. We're still in early stages. So we started focusing first on three things in order to help the developers. First is connecting to the underlying infrastructure. So ideally, DBT developers should be caring exactly on which system their models run on, ideally because it's not that portable, but nonetheless, we should ship them pre-configured connections so they don't have to worry about that. We currently support Impala and working close with the Cloudera tech team to also integrate Spark in our distribution. Manage access and security. So of course, we're generating data. We have to make sure it's secure and only the required people have access to it. Well, thankfully to this, where all the data resides in the data platform, which is already secured by the Kerberos and Ranger combo. So that was the job already taken care of. And the part I'm going to be actually focused on is code deployment and job orchestration. So we try to offer the tools and, let's say, templates and documentation for people to do the job easily, to be able to deploy their actual DBT models. Okay, so we started from, okay, so how do we orchestrate the jobs? Besides scheduling, you need to do a lot of things like gather logs, view run history, gather metrics, alert on errors, and so on. I'm not going to go on the reasoning. Airflow is the obvious choice. We've already had experience with it. It's kind of an industry standard, and it already had integration, some sort of integration with DBT. Like in DBT, you already have like an overview over model state, run status, execution time, and errors, but it would be like kind of trying to recreate Airflow if you're trying to gather all the logs, extract the data, and publish them somewhere. Okay, so we went on the DBT variant. So in order to run DBT in Airflow, you have like two options: Bash operator, even DBT operator, but that's like a wrapper around Bash operator, and Kubernetes pod operator. So Bash operator works by having a DBT and a DBT command line interface installed on your Airflow workers, while Kubernetes pod operator does what it says. It actually deploys a Docker container in Kubernetes, but you can pre-build the Docker container with all your DBT needs and run it over there. Things we've taken into consideration, things like dependency management, overhead, flexibility, and infrastructure. The reality is the dependency management was the critical part for us because we couldn't integrate it with our current development. And due to the fact that we already had like application container culture in eMAG. We had the support from our colleagues to do this kind of thing. Going on the Docker side, no, go back, Laurent. Okay, so going with the Docker, solution, you actually, okay, so you inherit flexibility and dependency management that's from Docker, and also solve a few other problems from us, like we could use Kubernetes secrets and not worry about integrating an external secrets provider manager, and we didn't have to worry about Kerberos tickets being generated on the Airflow workers for different users, and in general we could ship pre-built containers with configuration, with the connections already configured to developers so they can test their models locally if they want to. Can you go to the next slides? So the next slide, please. Sorry. Okay, so this is a very artistically made graph. It was done in a hurry. So the flow is kind of simple. So we pre-built, as I said, we pre-built the Docker containers with all their dependencies with dbt and the connections pre-configured. So the actual developer only has to interact with Bitbuckets, where they version their code, what Laurentiu was talking about, and define their scheduling in Airflow. And how it works is Airflow launches a pod in Kubernetes. It pulls the pre-built container from Harbor, pulls the code from Git and executes whatever dbt commands the developer asks of it. Now going back a slide. This is, okay, what I tried to show here was a really basic Airflow DAG. This is in order to show that we're not straying off from our initial mission, so we're not introducing complexity by going with this approach. So you basically can template this for dbt or a variant of it, and the developer only has to worry about providing the actual Docker image it wants to use and the stash repo where the code resides. There's the thing to say here. There are two ways of doing this. So both dbt and Airflow use DAGs for orchestration. So you can run the whole dbt DAG in an Airflow task. That's what we're doing here, but you don't have visibility in Airflow of individual models being run. Or you could pull the DAG from the dbt container and generate your lineage in Airflow. That's what we're trying to do. I don't have an example here, but we're trying to automate this process so the developers don't have to do it manually. Yeah, there's a few things I didn't. I'm looking at time. Sorry. There's a few things I didn't mention here. Things are like they're not second citizens to our development process, but we were focused on bringing dbt faster to developers. Things like data governance, that's quite a priority. We're working on automating the extraction of lineage from the dbt container and publishing it to Data Hub. Things like model testing for new version, that's a thing. Yeah, we're also working on. We're kind of oscillating between a test environment or actually running the dbt models against the production data. That would make a pretty more sense. But yeah, that's another talk when we have something in place.
Okay, thank you. So a few words about the challenges that we're facing. We have lots of infrastructure and lots of data and lots of code on premises. And most of the new cool stuff happens in the cloud. And this is a challenge for us because we want to use all that shiny stuff, but we need to put our work. And for example, dbt on Cloudera data platform is work in progress, and we're working with the developers of dbt Impala and dbt Spark to make it work on-prem. Updating data in the data lake is tricky. We're used to make updates on our data, and all our pipelines work like that. Doing this in the data lake is still tricky. There are newer advancement with newer table formats in this area with Iceberg and Delta Lake and Hoodie and Hive managed tables. But the thing is, getting those new technologies to work across the technology stack is challenging. So we're still working on that and trying to find a puzzle that brings us some, I don't know, interconnectability between all those pieces. Changing technology is caring for people, and this is why we're trying to make it as easy as possible for them. And yes, our tech stack needs to be simplified, and we're working on that. And I have one more slide. I said, Alex, I can talk about between 2 minutes and 2 days about this, but it will be 20 seconds. So we reorganized our teams according to team topologies rules. And we said we have a platform team, which is comprised of the former big data team, a BI core team that handles reporting. We also have a DevOps, DataOps team that helps us and that builds all that abstraction so that people can use the platform. And then we have lots of stream-aligned teams. These are teams that are doing work from start to end for everything data. They are doing data processing, they are building the models, they are building some default reports on those models so that we don't throw work over the fence anymore. So we were having ingestion in one team, then modeling in one team, then reporting in one team, and this would make us slow. So our target now is to have all the project work, the business work in one team. And we're also having enabling teams, in fact, a combination between enabling and complicated subsystem in our data science teams that they are using the platform, they are using the models that are built by other teams, they are building their own models, and they are helping other teams in the company use data science models. So this is all we had for today. Thank you very much. If you have questions, I guess we can take a few seconds. If not, you can find us around.
We definitely can take questions if you have any. I think I would have a curiosity. I would have thought it would be interesting to see some metrics on how many data you process and you interpret. Do you have this info now?
I have some data. We have some stuff in Data Hub, but the thing is, I don't trust it that much. For example, the data lake is now 1 petabyte. It's too round to be true, you know? And we are adding, how much? I think
Another 2.
at least doubling it.
Tripling it, yeah.
Yeah, so, yeah, there are around 1,000 reports in ClickView. There are a few hundred in ClickSense. There are some other 100 in Tableau. There are tens of thousands of data sets all over the ecosystem. So if you ask me, I don't know, and you'll be asking me some more, and when I know, it will be better. But at this point, I don't know how much is all of it. And this is why I can't tell how much it will take to migrate everything. And if I want to build a business case to migrate to cloud, for example, I'll have to say, well, I expect it will cost this much, but I can't tell for now. So we're taking steps, we're documenting things, moving things, and making sure the other things don't break along the way.
Thank you very much. I thought you would have many data. So any other questions? Thank you, guys.
Thank you very much.
Thank you for joining us.